Hi everyone, welcome back to another session by K21Academy, and today our expert trainer will be discussing about DevOps tools and its usage. So watch the video till the end.
Who should learn DevOps? This I told you, no. So you will be coming somewhere, no. Certainly you will come somewhere in this process, no. For example, you might be a developer, right? You might be a tester. Somewhere you might come. So all of you are eligible to learn something. For example, if you're a business analyst, learn the DevOps tools which are used for planning. Jira is one good example, right? Because business analysts normally use Jira. I will just write you might have heard and you might be using it also, Jira, for putting all the user stories and backlogs, for discussing about the requirements on how to place them, how many requirements they have to keep for this sprint, how much you have to give for other sprint, next sprint, all that they use. So if you are a business analyst, then use Jira. If you're a developer, host of utilities are available. No, you can use that. If you're a build engineer, mostly we will be discussing about Maven. There is also Ant, right? So there are a lot of other tools which are available. One of the tools you take and you learn. That means what? If you go in this order, for each and every role, there is one or more tools for you to learn. Okay. So when I ask the question, who should learn? So just consider your role today. You may not be knowing DevOps now, but you might be a tester. You might be a network engineer, right? You might be somebody. Understand that you have a role to perform with respect to DevOps. Tomorrow, when they are converting the entire project in DevOps, if you have the knowledge of one of the tools of your own role, then you are considered advantageous. Okay. So everyone has a role to play. Now let's go into the tools. I'm not going, as I said, this is just a curtain raiser. So we are not going to see each and every tool in detail. So let me give you that pretext. But at the same time, let's understand that these tools, how do they play in the big picture? Remember that not one tool is less important and another tool is more important. What is important here, I told you, no? So we are going to run a complete this thing, no? SDLC cycle, right? I have to start from business analysis. I have to write the requirements. I have to code, right? No, I have to test. I have to pass it through the EOT. Some automation might be happening in the testing. Then I have to deploy it onto production. So a lot of tools are involved, right? No, so the objective of whatever we are making is to learn some tools and understand that tool is there in which part of the SDLC cycle, right? With that context, let's just see how many tools are there. You see here. So for monitoring, I have Nagios and Prometheus. And then for orchestration, we are having Kubernetes and Swarm. And for configuration management, I have Chef and Ansible. Something which I am telling you might be somebody told Terraform. Terraform is also there. For deployment, why did they not put, continuous integration, they have put Jenkins, right? Travis CI. So when you see a phase, for example, when I see monitoring on the top, Nagios, Raygun, and Prometheus. You can either choose one tool or you can use multiple tools. They are all competitors. So you just see the feature, which feature is good for you or which tool you know. Just you can take that and understand. If you know Nagios, 70% of the features of Nagios will be there in Raygun also. Fortunately, most of these tools are built in such a way that you will be reusing the code and sometimes the code will be pre-written. Okay, as long as you are not a developer, you don't need to know the code. But without knowing the code also, using Nagios, you can monitor and write small scripts. There are script generators also, so you can use them. These days, there are a lot of helpers available, so you can use them and write. So these days, nobody is starting the code from the scratch. Even the developers, they don't start from the scratch. If you get into AWS, AWS writes the code for you, right? No? So there are a lot of helpers. So for now, you don't have to worry. Whichever place you belong to, whether you are belonging to deployment or testing, understand one tool better. For example, testing, you take JMeter. Understand the JMeter. You may not be the developer first, but take the code and then test it. And then understand how the code flows. There are something called breakpoints, okay, where the code exactly fails. That you try to understand. That is enough. Later, when you are gaining expertise, you can start coding. And for coding also, a prior knowledge of C++, Java, that kind of thing is not required. You can directly start coding JMeter. You can directly start coding Nagios because they have a separate set. When you understand the overall picture, you can take the reusability concept. The sources are available in the internet. Sometimes people put the code, actual code, in the GitHub itself. You can take that code and just modify here and there. That is enough. Later you can do that. Now you can take the code and understand. That itself is good. So when I say tools, keep all your worry about, do I need coding knowledge at the back seat? Not required. No. Understand the tool from the tool usage perspective. Then let's worry about the coding. Okay? Right. So these are some of the tools which we are seeing. We will, at maximum possible, we'll see, try to see one more. Right. DevOps on AWS cloud. So the advantage earlier when we started discussing, no, I told about the cloud. If you remember here, right? No. So this point, cloud came into picture. Right. How did this cloud come into picture? What is the advantage that cloud has over these things? See, initially when they started the cloud, they said that we will take care of your infrastructure. As I told you, if you need 6 servers, we will provide you 6 servers. Tomorrow, if you need only 2 servers, I will do the elasticity and scale down. Okay, scale down your requirement only to 2 servers. Day after tomorrow, if you require 10, I will expand it to 10. Whatever you use, they call it as pay per use, no? Pay as you go, something like that. So like that, whenever there is a need, you give the infrastructure, we will give you the infrastructure, you pay only for that. That is how they started. Then they understood that they have a big market to play. They have started making something called web services. Okay, what is a web service? For example, now I'm saying I'm giving you a server, okay, from cloud. Then I see that you are using login password. Okay, always you're writing the code for login password. You're using some language to write the login password code. Now I'm saying that you don't have to write the code. I have a web service for login password. I have already written it. You can just come in and input all the variable parameters so that the code will be ready for you. Something like a code generator. Okay. If they do that, how easy it will be for somebody to come inside the cloud and make advantage of these services so that they will not spend much time in coding. So when they see, they saw a lot of services, web services. So they took each and every web service and they said, we are providing this. You don't have to code. You take our service, make some modifications, minor modifications which are required. For example, you want to place your company logo here. Then you want to use submit instead of confirm. Change the button to submit instead of confirm. Some minor changes. Other than that, the web service for login is already ready. If somebody says to you how easy it is, no? So you just have to use some Excel sheet to provide the data, but the code will be generated automatically. You at the very crux, I'm telling very superficial level. Web service has got a lot of usages, but I'm just telling you. So they have started. That's why they are called as cloud service providers, right? No, providers, cloud service providers, not just infrastructure. They are providing you web services also, right? No, so now the example that we have taken now, first thing is AWS, correct? No, DevOps on AWS cloud. So you know this plan, complete thing, right? Plan, coding, building, testing, deploy, and operate. This we know already. We have seen n number of times. This is the SDLC life cycle that we are having. So each and every phase, plan, code, build, they are all having different tools. So AWS is having lot of services which are catering to the needs of this. For example, code. So what is continuous integration? I'm just giving you bits and pieces, but later we will see there's a big chapter for continuous integration in Jenkins. So we will see that. What is continuous integration? Let's just see, take a code, no? A developer, right? No, he is coding. Now I told you he will put the code in a repository, right? Now this code version is 1.1, right? 1.2. He is making a new version. Okay. Now what he will do? He will put the new version also into the repository. So you have 1.1, you have 1.2 also, correct? No. Then at some point of time he will make more changes. 1.3. He will put 1.3 also here, right? No. All these are codes which are stored in the repository. Okay. Now, let's say 1.1 went to testing. He deploys. You remember, I used the word deploy. He is deploying this code into testing. When 1.2 is coming, he has to deploy this 1.2 onto testing. After some time, he made 1.3. He has to deploy 1.3 onto testing. This is manual deployment. But continuous integration is a process which says as soon as the code is deployed onto the repository, it will automatically be deployed onto the testing. This is continuous integration. How easy it is, no? Let's say, for example, you are making some change. Okay, in your bank account, you are making a change in your address. Correct? No? For example, now this is your banking profile. They call it as customer profile. No, customer profile. Now within banking, you are having stocks. You are having loans. Okay, you are having, let's say, banking. Right? No? You are having different services. You are availing different services. In stocks, you go and change your address. Okay, then it's the website in such a way that in loans also you have to go and change the address. In bank also you have to go and change the address. But what if I say you change your address in a different module? There is a separate module called address. If I go and change my address in this module, it will get reflected everywhere. You don't have to do it in each and every module. Do it once here. It will all be reflecting in all your stocks, loans, and banks. It becomes very easy, no? In the same way, if the developer has to put all the code in the repository and then he has to take it to deployment into testing, sometimes he may forget, right? No, but if I say the moment he puts the code into the repository, it is automatically taken to testing. 1.2 comes inside, immediately it goes and deploys into testing. So testing team will get the latest code from the developer, and that is called as continuous integration. This goes on, you see, go code and build. You are building it and then you are putting it into testing. So this is continuous integration. What is continuous delivery? The moment you are testing it, if every time it goes to production, right? As soon as the testing is over, it is automatically taken to the production, continuous delivery. So that means without your knowledge, without developers' knowledge, as soon as the 1.2 is put into the repository, it will be taken and deployed into testing. Testing will be done automatically. Once that all the test cases passes, it will be taken and deployed onto production. This is continuous delivery. So if you are having continuous integration and continuous delivery, this is what is called as CI/CD. That's what people call, no? That's a craze that they have, that it should have CI/CD. What is the advantage? The developer is writing the code on Monday, right? No, on Monday night he deploys. The tester starts to test on Tuesday, right? No, he tests it until, let's say, Thursday, right? Then the code is being deployed onto UAT. The UAT tests for 2 days, right? No, so on next Monday, right? No, it goes for production, right? No, so that means it takes so much time because there are manual interventions. See, I'm just giving an UAT also can be done. Concept user acceptance testing is still required because the way the users test, no, that will be different. Their thought process is different. You still need the concept. Okay. So what happens now? On Monday, the code is automatically deployed from development to testing because I have continuous integration. Here, the tester need not wait till Tuesday morning because the next day he comes, no, but the testing will be done automatically. There are some test cases, automated test cases, which will be picked up. As soon as the deployment happens, the test case will automatically run and they will give a report. The report will say if 70% of the test cases are passed, deploy it onto UAT, right? Here, UAT also can have some automated test cases. If those test cases, automated test cases are also passed, let's say 80% of them is to be passed. You put just a condition. If 80% test cases are passed, which means what? If you have 100 test cases, 80 test cases should pass. If they are passed, take it to the production. And When the tester comes next day, Tuesday morning, if everything goes fine, instead of starting the testing, he will find that all the reports are ready for all the phases, and now the code has gone to production. You will save time, right? No? And you will save manual errors also, because these are all scripts that are already available. They will be picked up automatically, just like they call it as jobs. One job finished, another job is taken. Another job is finished, next job is taken. So they will be taken automatically, and then finally they will go to production. If need be, on Wednesday itself, you can see them in production, because all the test cases are automated. They are passing the phase by phase, so you are saving time. And that's why the companies, the organizations are very keen to implement CI/CD, so that there are no manual interventions. The moment a new code is coming, it will be taken to the next levels by CI/CD, so that next day morning itself you can find the new code in the production itself. That is what is a simple terminology I'm saying. CI/CD is a huge chapter, but on the whole, if you want to understand in single line, CI/CD is nothing but automatically taking the code and passing it to the next level. If there is a failure, you can handle that. For example, instead of 80%, if it is 79%, it will stop here. It will send SMS to all the stakeholders. Test cases have failed. Please have a look at it. So people can come the next day and then correct that, rerun it. It can run. So you can do error handling, right? No, you can do exception handling. You can do automation. You put all of this together and you achieve CI/CD. As I told you, you can fix how much test cases have to be passed. You may be having some importance. The test cases have passed 80%, but there is one critical test case. Okay. If this fails, 1 into 0 equal to 0. Even if 80% passed, if that one critical test case fails, don't take it. Stop it to production. So this kind of things also can be done. So all this will come as reports. The reports can be sent as SMS. The reports can be sent into your email IDs. Next day you can come and read the reports, and accordingly it will be there in the production. Got that? No? So this is called as continuous integration and continuous delivery. Right? So there are tools which are helping you for that in the AWS world. How we can just make the continuous deployment, right? Right. Let's go ahead and see the code repository. There are multiple code repositories which are available in the market. The most popular among them is Git. Okay. As you know now, Git is being bought over by Microsoft. Okay. It's a Microsoft product. And I'm also hearing that, they are having a complete control. So later we will see that, in fact, last time we saw in our AWS Azure, we didn't see them. Okay, here somewhere, you can see here, unlimited cloud hosted private Git repo. Remember, Azure is a Microsoft. Okay, Microsoft has very well integrated the repository, his repository with Git, because he has already bought over the Git. No? So he has integrated. Doesn't mean that you cannot have Git. I have got a free version of GitHub. So anyone can make. So when people who are learning DevOps, they will know that you can just go to github.com. You can open your account. No problem. You can sign up. So this is available. But just remember that once Microsoft is completely taking it over, maybe it might be made into a commercial site. Now it is community only, so anyone can make. Right. Now, what is a Git? A Git is a version control system. Now, what is a version control system? As I said, we are not going to learn in detail, but I'm just telling you a highlight of what is a version control system. Okay. Hey, code. Okay. I'm pushing the code. Right. Now the code is becoming 1.1. Now I'm pushing the code where? I'm pushing the code into a repository. Why do I need a repository? I need a central place to store all my codes. I cannot store it in my personal laptop. I cannot store it in my own server. Why I cannot store it in my own server? It is not globally visible. A GitHub is a distributed, remember, it's a distributed version control system. What do you mean by distributed version control system? Nowadays, we are having projects in all directions of the world. No? A developer is sitting in New York. He is coding something. Another developer is sitting in Delhi. He is coding something. Another developer is sitting in Singapore. He is coding something. They all make changes to the same code. For example, bank.c. They are making same code. They are making changes. So what you could do, New York, since he is coming, for example, if he is coming early, then what he would do, he will do changes to the banking.c, and they call it as he checks in. They call it as check in. Just like you're checking your baggages, and once you're checking in, it is going into some central place, and they are storing it in the in the plane, in the flight. So you're checking your code into the repository, which is in our case Git. Now the person who is sitting in Delhi, who is coming in the next week, can see this. So when he needs, he can check out. He can check out. You call it as check in and check out. When he checks out, what happens is the same code is ready, but if he makes even slightest change, for example, he adds one A to this code. When he checks in back, when he puts the code back, automatically it becomes 1.2. You don't have to make any version change. When there is any change to the code that is happening, it becomes 1.2. So who made the change? It will be available here. The information metadata will be available here, right now. GitLab is an overall control. GitHub is only code repository. Git will come to GitLab also. Just give me 2 minutes. We'll come to GitLab also. Now 1.2, if this is being taken over in the next shift by the Singapore developer, it is available. 1.2 is available for checkout, but he makes changes and puts in, it will be 1.3. When the New York developer comes next day morning, he will see that he gave 1.2, but all these developers have changed it to 1.3. Now he can go and see each and every code, version of the code, and see what is being changed. Okay, so he will see that something has been added here, something has been deleted here. So a distributed version control system will have complete transparency, okay, of who does what. If a code fails, you can easily identify because of which version the code has failed, right now. And most importantly, it is available in one place, right now, GitHub. So it is one place where everyone can access, right now. That is the advantage of GitHub. GitHub has got several other advantages. So while we learn the GitHub as a tool, we will just know how to make easily the check-ins and checkouts, and how the functionality happens. All that we can learn, but just understand that Git is nothing but a code repository. I told you build. What does build do? A developer develops the code, correct? So what are all the different codes that he has to build? He has to build the core code. Then he has to build some config file, right? No, he has to do some data prep. He has to put some environment variables, right? No, then global functions. All these things are part of code, and there might be some, third-party code also that he might do that. We have been doing it. Third-party tools, we use that, and then we change the code and we put that. The build engineer packages all these things and takes it as one single package before it is being deployed onto testing team. These are all different codes, but they are being packaged as one build. Okay, when it goes to testing, it goes as one build. There is a mvn.mvn file. So this might be a C file. This might be a C++ file. This might be a Java file. They are all taken together. They are being built into one Maven file, one or two or whatever. It is concised into one Maven file, and the Maven is being put into testing. Okay, so it's something like a zipping. They zip the things, and Maven is one tool which is being used for that. So I can see here, the build process has source code. It has got test scripts. It has got some libraries, right? All these things are taken as a build file. You do the build process, and then you say the report that I have done everything, right? I've done all that. And if you want, I can give the artifact also. Whatever artifact is that I'm giving you. So you're compiling all the things together, and when it goes to testing, it goes as one single thing. Remember, developer is different, build engineer is different, and Jenkins, that is deployment engineer, is different. Previously, developer only used to do all these things, but now it has become so complicated. Our codes have become so complicated that developer is doing only the development job. The build engineer is taking all the developer's code, and then he is compiling it into one build file called as Maven file. Here you can see, Ant and Maven are popular tools. He is compiling that, and then he is using the build process. In the build process, things may fail. If something fails, the build engineer will return the code to the developer. He will say that functionally it's not working. While I compiled everything, it failed. The developer will correct the test scripts, source code, everything, again give it back to the build engineer. The build engineer will compile and build it. If it passes, then he says report is ready. And that build file only is given for the testing team for deployment. Okay? So Maven is doing that job. Testing tools, I think we already know. Selenium is an automation tool. Okay, it is an open source freeware which is existing for the past 15 years. I have been using Selenium. I mean, past, I have forgotten that, but I've been using Selenium since 2006. I remember. So it was very a small freeware kind of thing. Now it has become an open source big tool. I mean, Selenium is competing with all testing tools. It is an automation tool which you can use. And there is something called JMeter also. Mostly Selenium is used as a tester automation. JMeter is used as a developer automation. Okay, so both are being used as a testing products only. See, these days, what they do in testing is, normally, how do you do testing? You build the code, correct? No, you package the code, and then the tester is going to have test cases, 10 test cases. He will execute each and everything, and he will say functionally passed. Correct? No? Functionally passed. 10 out of 10 test cases, all passed. That's how we will say. Now what they are doing, no? They are first writing the test cases. They are writing the code for the test cases. Okay. And then they are testing on a blank application where the code itself is not there, which means that they are just running the test scripts. When they are running, it will say all fail. Okay. When there is no code, how will it pass? So it will fail, no? Then they will create only login application, only code for login. They will run it again. Only login will pass, all others will fail. Then they will create, the developers will create login plus banking. Again, they will run. Okay. And they will see that only 2 test cases are passed. So like this, they are running again and again. First they are testing and then they are developing. Right now, these days they are doing, and these days they are called as software development engineers testers or engineering testers. Software development engineering testers or something, which means you need to have a development knowledge. Earlier I told, no, black box testing, where you don't need to know the code. These kinds of testers should also need to know the code. Okay, that's the difference. But these days, these SDAT testers are more, which means you need to have JMeter knowledge more. But Selenium is also industry-wide popular. You can learn Selenium also if you're a tester. CI/CD, I told you. So I can see a brief, note of how CI/CD is being developed. For all these things, they are used in Jenkins only. And the competitors of Jenkins are Bamboo, Circle CI. All these people are competitors, right? So I can use any of them. Travis, I think, is a commercial tool. You have to pay, but Jenkins is a freeware, and even Bamboo is freeware. You can see that this is an integration tool, whereas GitHub is just a repository only. In fact, that's what they would have explained here also. You can just have an introduction about Jenkins, and you can see Code Pipeline is the example for or competitor for the Jenkins here. So Code Pipeline does the same thing. So it takes the source code, it does the build. After build, it is given to testing. From testing, it is put into staging. This is what you call it as UAT also sometimes. And then it is sent into production. All this, the pipeline only takes. It is in the pipeline that you write the script in order to take it stage by stage. In the pipeline also, you insert the test cases. You say, if the test cases are passed, take it to testing. If the test cases are passed, take it to staging. If it doesn't pass, then get it back to testing. Don't deploy anything. Send an email. So all these are done by Code Pipeline. They are also done by Jenkins also, right? So AWS has also got the CI/CD pipeline. So again, you can see that it's all the same, right? You're having a code commit, which is repository. You're building it, you're deploying it. Finally, you're taking it to all the servers, whether it is going to be QA or staging or production. All are same. Whether it is Code Pipeline from AWS or Jenkins separately, independently, or it is going to be Azure CI/CD, they are all the same only. But They are all competitors. One from Microsoft and one from Jenkins is independent, and one from AWS, as we know. Right now, so Google Cloud is also there in this entire race. We forgot Google Cloud. They are also there, and you can see here. No, we don't need to know individually the components, but you can see that code, build, package, and then operate. So this is the general cycle that they follow. Right now, GitLab you asked, no? So GitLab is suite of tools for managing different aspects. So I can see here that Redis is something that is they called as in-memory database. It is a temporary memory database they are having. Then you are having the permanent database called as PostgreSQL. They combine everything, and then let's say, for example, Nginx is the one where it is going to host all the pages. For example, let me say my accessbank.com or my ICICIbank.com, right? ICICI. So this is running on a web service, Apache kind of thing. Okay. So this they are hosting it on an Apache server. And this is what you are seeing here. That's Nginx. Okay. Nginx is an Apache server where it is written, and all the pages, right, which is being developed by all these things. Okay. So your database, your in-memory database, and all your the shell and all the development scripts are being hosted here, right? So this is also a kind of complete end-to-end that you are having. So GitOps is also kind of continuous integration and continuous deployment only. See, there are two words, no, continuous integration, continuous deployment, and continuous development. Continuous delivery. You can see here, no? Continuous integration is up till the test. That is, if you are automatically taking the code to the testing, it is called as continuous integration. If you are taking until release, that is just before production, then it is called as delivery. If you are completely putting it and deploying on the final production itself, it is called as deployment. So all these things put together is only called as DevOps. If you are using DevOps, you are using Jenkins, you are using GitHub code repository, right? You are using some tool for testing like Selenium. So all put together only are called as DevOps. So these are all, again, all these are alternative Argo CD. I don't know whether you are going to use all these things. I don't know whether it's included in the syllabus, but just remember that these are all competitors for the same market. No, so they are trying to capture the CI/CD market. Now, by the way, what is the declarative statement? This is very important. These days, declarative programming is becoming more popular. What do you mean by declarative programming? Let's say I'm having Oracle, I'm having PostgreSQL, right? No, I'm having NoSQL. These are three different databases. Okay. You see, if I have to insert something into Oracle, if I'm following this database, if I'm saying I have to insert something into, I have to clearly give the syntax: insert into table values. Okay. Then I have to give the values. Then I have to put comma. This is one full statement for Oracle. But if I'm going for PostgreSQL, maybe this will change. I'm just giving you an example. Okay. Insert into tables. Okay. Instead of comma, let's say colon. If this is the syntactical change, then you have to give this syntax to enter into PostgreSQL. If it is NoSQL, so you will say update something simply. So different database follow different syntaxes. If you are giving exactly the command to say that you have to use this database only, Oracle only. So I am giving you insert into something, that is called as imperative statement. Right? No? Sometimes you might have seen, no, some people are doing micromanagement. Some managers are there. They will exactly tell you what to do step by step. Right? No? And you'll have to follow them. But some managers are there. They will be saying, you do this by today evening and tell me. However you want, you can do. But do it and tell me. Declarative statements will only say a declarative word, which is not imperative, which is not saying you have to do this. In declarative, the advantage is if you say insert, okay, something, if Postgre is followed, then it will automatically take the Postgre syntax. If Oracle is followed, it will take the Oracle syntax. So it is flexible. Declarative statements are flexible no matter what database you pick, Declarative case statements can choose that. Okay. So imperative statement means you are clearly giving the syntax. So this code will not work in Postgre. Imperative statement code will not work in other databases or any other source. But declarative statements are commonly written that you can apply them. What is the advantage? Tomorrow, if you are changing the database, or tomorrow, if you are changing from AWS to Azure, you don't have to rewrite the code if you are writing it in declarative statements. Now you can understand, no? Argo CD is a declarative statement. Correct. Compatibility. Declarative means what? If you do the Argo CD, the deployment, this tool, then tomorrow if you are changing something, you don't have to rewrite the code. It will automatically see if it is compatible. Then it will run the code according to the tool which you are connecting. You don't have to rewrite the syntax. Circle CI, all these are just competitors you can just imagine, right? Now let's quickly go into Terraform and Ansible. See, for now, what all the things that we have seen, you know what is a code repository, right? No? Git is the example. You know what is the coding tools, Java, C++, Node.js. These are the tools. What are the tools for continuous integration and continuous deployment? Jenkins, right? No, you know Circle CI, Circle CI. These are the tools. Argo CD, right? No, these are the tools that we have. Now we are coming to another thing called as Terraform and Ansible. There is something called configuration management. Okay, what do you mean by configuration management? I told you an example, if you remember, that there are 10 laptops. Okay, and in all these laptops, they all belong to the development team. These laptops have to be same, no? The pattern has to be same. There has to be a Linux operating system for all. These developers are belonging to the same thing, no? Now these, no, all are same developers, no? They are belonging to one team. So they are all belonging to Linux. They are all having the same set of applications, security patches, everything. Will you go and install these utilities one by one? No. What you will do? You will write a script. This is called as infrastructure as coding, IAC. When you write a code and when you just run the code, this will identify all the connected laptops. Each and every laptop is called as a node. It will identify the node. The node is not only the laptop. The node can be a server also. Okay. And you can say that for all the nodes that are connected, install, let's say Microsoft, install Unix, okay, install Microsoft Office. What will happen? At one shot, all these things will get the software, okay, we'll get the utilities, we'll get the patches, we'll get the operating system, everything. You are not going and deploying it each and every machine, but sitting in one place, you write an infrastructure as code, which is nothing but what should each and every node possess. And the best part is this will always be connected as server and client server. If there is any change that is made here, the infrastructure as code, the configuration management will see that some change has taken place. It will come down, it will remove that and put it in the same way, right? No, for example, I know that I think you know that, you know, all these franchises, you see Subway and you know, all these you know, McDonald's, everybody. Why can't they sell sweets, right? No, all your you know, halwas and whatever. Why can't they sell that? The sales will be big, no? They can earn, no? By selling biscuits, chocolates, everything. They can make the entire McDonald's into a supermarket, mini supermarket. No, they cannot make. Why? Because if the McDonald's franchise owner comes and sees that these are not the things according to my protocol, you should sell only burgers. Subway, you should sell only subs. What will he do? He will remove all the extra items and he will say, as per protocol, you are my franchise. You should sell only these things because this is the protocol. The same way, if one of the nodes or installing something which is not as per the protocol of IAC, it will see, it will come and it will change to the original thing. That is called as idempotency. Idempotency is nothing but not only installing the same tools and patches across all the nodes, but also monitoring that they are following the protocol. If somebody doesn't follow the protocol, he will come and wipe out the extra thing and he will reinstall what is available in the source. See, Ansible and Terraform or IAC, but Ansible is more of it's going into more of a infrastructure as a code for making all the utilities on hardware, whereas Terraform is something which is multi-cloud kind of structure. For example, in Terraform, how you will use is you say, I require 3 instances. Okay. Now, if you use Terraform, it would say that 2 instances I can take it from AWS and 1 instance I can take it from Azure. So he sits above the cloud service provider. He is becoming the central source and he decides which is optimal for you. For many reasons, it could be that 2 instances taken from AWS will be better and 1 instance from Azure will be better. You need 3 instances. If you are left alone, you will choose all the 3 in either AWS or Azure. But if you take Terraform, it optimizes your need and it makes a complete blueprint of how your project, it decides by itself. Little bit different, no? In Ansible also it does that, but it's mostly from the the infrastructure management, that is configuration management perspective. Here the complete management is done by the complete infrastructure management itself is done, right from choosing which is to be taken, which is to be left out, all that. Tomorrow I can even say that I think this is proving to be little bit unproductive. Make all the 3 instances. This you can make. For that you can write an IAC script. Here you can say I want 3 instances. In Terraform, you will not say I want 3 instances from AWS. You will only say I want 3 instances. What was it called? Declarative statements. Right? No? Time to time, Terraform will decide whether all the 3 should be taken from AWS or 2 plus 1 or 1 plus 2. Everything will decide. You will only make a declarative statement. Terraform will decide. So that is called as infrastructure as code. So both are IAC, but the way in which their scope is defined is a bit different. Right, infrastructure as code, I told you this way. Right, Terraform infra automation, then Ansible is config management. Just you can read that this is infra automation. It chooses multiple things. You see, it also has Google Cloud. It also has AWS. It uses Kubernetes. All together, you can manage it here. If you want to make any change, you don't go in AWS and make change. In this code, you make change as a declarative statement. If that impacts AWS, Terraform itself will come and make that change. That is a big difference. Okay.
So guys, this was our expert from Team K21Academy. And if in case you want to have a deeper dive about the concepts discussed, then we have something really special for you. We have our free class on DevOps for beginners, what, why, and how to get higher paid jobs. So if you want to register for the same, then all you have to do is just log on to k21academy.com/DevOps02. You'll be seeing this kind of interface. You just have to click on book your free seat now, select an event date, enter your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of link on the extreme right. You can save that link, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.